90% of DevOps interview candidates fail in the first 5 minutes, not because they don't know the tools, they fail because they cannot answer the most basic question any hiring manager asks: what is DevOps? I have interviewed over thousands of engineers from fresh graduates to senior architects. I have rejected candidates who had 5 years of Jenkins experience because they could not explain why DevOps exists. Today, that ends. Welcome to Inside the Interview Room DevOps Edition. This is the first episode that I'm creating on what is DevOps. I'm your host. I spent 18 years building, breaking, scaling platform across banking, SaaS, healthcare, and telecom industry. And for the next 45 minutes, I'm pulling back the curtain on exactly what happens when the camera turns off and the hiring manager makes the decision about your career. Why this video is different. Before we jump in, let me tell you what makes this channel different from every other DevOps tutorial on the internet. Most DevOps content teaches you how to configure Jenkins, how to write Docker file, how to set up Kubernetes cluster. That is useful, but it is not what gets you the job. What gets you the job is understanding why, the context and the story behind every tool and practice you have ever used, because the hiring manager sitting across from you is not testing your memory, they are testing your judgments. In every episode of this channel, I will simulate the exact questions I ask in real interview, tell you what answer I am looking for, show you what the average candidate says, and then show you what the candidate who gets the offer says. Let's begin with the episode one, the most fundamental question in all DevOps interview. Whether you are a fresh graduate trying to break into your first DevOps role, software developer looking to pivot into the platform engineering, or senior engineer preparing for a director level interview, this episode will give you something you cannot find in any documentation, any course, any textbooks. Here is what we are covering today: what DevOps actually means and why it was invented, the fundamental shift from traditional IT to DevOps operating models, DevOps culture, the part most candidates completely ignore, the full DevOps lifecycle, core principles every engineer must be able to articulate, roles and responsibilities with real example. Then we go deep on each stream: CI/CD, infrastructure as a code, container, Kubernetes, monitoring, DevSecOps, cloud, platform engineering, and SR. And this is where it gets real. I will walk you through 10 interview questions across 4 difficulty levels. I'll tell you the expected answers, what the wrong answer sounds like, what follow-up question I will throw at you, a real production examples, and pro tip that only senior practitioners knows. After that, I'll give you the insider view, what hiring manager actually look for, what instantly cause rejection. First question: what is DevOps? DevOps is not a tool. It is not a job title. It is not a team. DevOps is a philosophy, set of practices, cultural norms, and automation principles that unify software development and IT operations to deliver software faster, more reliably, and more securely. The formal definition of DevOps is a combination of cultural philosophies, practices, and tools that increases an organization's ability to deliver application infrastructure changes at high velocity, evolving and improving products faster than organization using traditional software development and infrastructure management process. The world itself is going in a fast phase of development and operations, but the transformation in it represents is a far bigger than naming convention. Why DevOps was invented? In early 2000s, the software company operated in silos. Development teams wrote code, operation teams deploy it. There was a massive wall between them, metaphorically and sometimes literally. Developers would throw code over the wall to ops. Ops would deploy it and it would fail. Ops blamed for bad code, dev blames for bad infrastructure. Meanwhile, the business was suffering. Release cycles were 6 months to 12 months. Bugs lived in the production for weeks. Innovation moved at the speed of bureaucracy. In 2009, Patrick Debois organized the first DevOps Days conference in Belgium. The conversation that started there changed the industry forever. The core insights was simple but revolutionary. What if development and operation teams work together, share responsibility, and automate everything that could be automated? That insight became the DevOps movement, and it was turbocharged by three forces. Cloud computing made infrastructure programmable, agile methods made delivery iterative, open source tooling made automation accessible to every team. So, what is the difference between traditional methods, traditional models, and DevOps models? In traditional model, requirements gathered over months, developer code for months, QA test in isolation, operation deploys once, rollback is manual and painful. Failure is hidden until it is catastrophic. In the DevOps model, requirements broken into small user stories, developers commit code daily, automated test runs on every commit, continuous delivery pipeline deploys to production multiple times in a day, rollbacks are automated, failures are detected in seconds, not in months. Difference is not just speed, it is a feedback loop. Traditional model have feedback loops measured in months. DevOps compresses those loops to hour or minutes. The faster you get feedback, the faster you learn. The faster you learn, the better your product is. What is DevOps culture? The most ignored topic in every interview. Culture is the hardest part of the DevOps and part of most candidates completely skip in interview. Let me tell you something. If a senior director asks you about DevOps and you only talk about tools, you have already lost. DevOps culture rests in four pillars. First, collaboration. Dev and ops share responsibility. Nobody throws code over the wall. Second, shared ownership. The team that builds a feature also monitors it in production. You build it, you run it. Third, continuous learning. Every incident is a blameless postmortem. You learn, you improve, you never repeat the same mistake. And fourth one, experimentation. The failure is not punished. It is analyzed, feature flags, canary deployments, A/B tests. These are the cultural artifacts as much as technical ones. The companies that fail at DevOps are not the ones that buy the wrong tool. They are the ones that rename their operation teams to DevOps and change nothing about how people collaborate. So, what is DevOps lifecycle? The DevOps lifecycle is an infinite loop, one often called the DevOps infinity loop. It has 8 phases: plan, code, build, test, release, deploy, operate, and monitor. Then it loops back to the plan, informed by what monitoring tool reviewed. So let's see one by one. Plan teams use tools like Jira, Azure boards, or Linear to plan sprints, manage backlogs, and track work. Code developers write code using IDs, commit to Git, and raise the pull request. Build CI tools like Jenkins, GitHub Actions, or GitLab CI automatically compile, build, and package the application into the binaries. Test automated unit testing, integration testing, security scans, and quality gets run before the code is merged. Release pipeline creates deployable artifact like Docker image, jar, var, or any other binary artifact. The next is deploy. CD pipeline deploy the artifact to the target environments like dev, QA, staging, and production. Then operate. The deployed application runs and is managed through the infrastructure automation, Kubernetes operators, and SRE practices. Then last but not least, monitor. Observability tools like Prometheus, Grafana, Datadog, Dynatrace provide metrics, logs, and traces inside feedback into the next planning cycle. What are the DevOps principles? The foundational principle of DevOps are captured in the CAMS framework: culture, automation, measurement, and sharing. Later expanded to CAMS with lean. Culture. What is culture? People and process before tools. Automation, eliminate manual toil, automate, builds, test, deployments, infrastructure provisioning. If a human does it twice, it should be automated. Lean, apply lean manufacturing principles, eliminate waste, optimize flow, reduce batch sizes. Measurement, what you cannot measure, you cannot improve. The four DORA metrics: deployment frequency, lead time for change failure rate, mean time to recovery. These are very important. Sharing, knowledge sharing across the teams, shared runbooks, shared dashboard, shared blameless postmortem reports are very important. If candidate can articulate CAMS and DORA metrics in single answer, they have already separated themselves from 90% of interviews. What are the roles and responsibilities of DevOps? A DevOps engineer wears many hats. Core responsibilities: designing and maintaining CI/CD pipeline, provisioning and managing cloud infrastructure using IAC tools, containerizing applications with Docker, managing them with Kubernetes, implementing, monitoring, alerting, and observability, automating security checks in the pipeline, collaborating with development teams on deployment strategies, managing secrets, certificates, and access controls, writing runbooks and documentation, conducting incident response and postmortem, driving SLIs, SLOs, SLS definition with engineering leads. The key inside a DevOps engineer is not a gatekeeper, they are enabler. Their job is to build platforms and process that allows development teams to ship software confidently and independently. So there are different streams of DevOps like CI/CD, infrastructure as a code, containers, Kubernetes, monitoring and observability, DevSecOps, cloud computing, platform engineering, and site reliability engineering. These are the different streams of DevOps. What should be the career roadmap of a DevOps engineer? The DevOps career path here is the most common progression: junior DevOps engineer 0 to 2 years, DevOps engineer 2 to 5 years, senior DevOps engineer or DevOps lead 5 to 8 years, principal staff engineer or engineering manager or director 8 plus years. The skills every DevOps engineer must master are Linux fundamentals. You cannot survive without the command line fluency, networking, TCP, IP, DNS, load balancers, firewalls, VPN, etc. At least one scripting language you should know: Bash, Python, PowerShell, or any other scripting language. That is mandatory. At least one cloud platform. AWS is the most common. Azure has the strong enterprise presence. Any other GCP, OCI you can study or you can have the hands-on. One IAC tool like Terraform is the market standard now. Pulumi, Crossplanes, there are other IAC tools as well. One CI/CD platform like GitHub Actions, Jenkins, or GitLab CI, anything. Docker and Kubernetes are non-negotiable from senior level onwards. Observability, metrics, logs, traces that you need to know. Security basics, DAS, SATs that we manage, secret management, RBAC, etc. Version control with the Git, branching strategies, and GitOps. The soft skills that separate good engineer from great leaders: communication across the technical and business stakeholders, incident command, staying calm under fire, influence without authority. You will need to convince teams to adopt practices without direct reporting authorities. Documentation, the ability to write clear runbooks and architecture design records, and most critically, the ability to say no. is a way that gets you yes. Explaining why a shortcut will create 3 times depth downstream. Now let's move to the interview questions. 10 questions, 4 levels, full breakdown. So now we get into the real interview room. I'm going to ask you 10 questions exactly the way I asked them in real interviews. For each one, I will tell you what I expect to hear, what most candidate actually says, and what the candidate who gets the offer says. Let's go. The first question, what is DevOps and why it was introduced? The expected answer, I would expect DevOps is a culture and technical movement that unifies software development and IT operations to enable faster, more reliable delivery of software. It was introduced because the traditional model had siloed development and operation teams with slow feedback loops, manual deployments, and 6 to 12 months release cycles that could not keep pace with the business demands. DevOps emerged from the Agile movement and was formally named at the DevOps Day in 2009. Its core goal is to compress and feedback loop between the writing code and seeing it in production. What is hiring manager is expecting? I am the hiring manager. I want to hear 3 things: an understanding that DevOps is culture first, and sense of historical problem it solved, and at least one concrete outcome it enables. Bonus points for mentioning comms or DORA metrics. What is the wrong answer? So every time I interviews the DevOps uh, interview candidates are mentioning DevOps is about tools like Jenkins, Docker, automate deployment. It makes deployment faster. This answer shows tool knowledge but zero understanding of culture, history, or organizational problem being solved. That is instant uh, a red flag. What can be the follow-up questions that I would ask? What are the 4 DORA metrics and why do they matter? How does DevOps differ from Agile? Can you have DevOps without Agile? What is the biggest blocker to DevOps adoption in large enterprises? Like in real world, at fintech company I worked with, the operation teams would receive deployments requests from the development via ticketing system like Jira. Average turnaround 5 business days after implementing DevOps practice, shared pipeline, shared ownership, automated provisioning. The same deployment took 12 minutes only, end to end. The change failure rate dropped from 22% under 2% within 6 months. Pro tip, start your answer with the problem, not the definition. Hiring managers want to know you understand the business context. You can say the problem it solved was before you say DevOps is. This is structure immediately signals the senior level thinking. The second question that I would like to ask, what is difference between continuous integration, continuous delivery, and continuous deployment? This is the question that's where most of the candidates feel to differentiate between this continuous delivery and continuous deployment. What I expect from the candidate. Continuous integration is a practice of merging code changes to shared branches frequently, often multiple times per day, with automated builds and tests running on every commit. The goal is to catch integration issues in early phase. What is continuous delivery? What I would expect, continuous delivery extends CI by ensuring every code changes pass pass the automated test in a deployable state and can be released to production at any time, but the release decision is made by human. Continuous deployment takes one step further. Every code change that passes all automated tests is automatically deployed to production with no human intervention. No human intervention. This is the complete automated process. Most enterprise practices continuous delivery rather than continuous deployment due to compliance and risk requirement. Like Google, Meta, Amazon, these companies follow the continuous deployment process. And most of the time, the banking industry or any other telecom domain follows the continuous delivery. So, where human approval is required. So, what I would expect from the candidate, candidate must clearly distinguish between the delivery, human gate before production, and the deployment, no gate. It's automated. Many confuse them. Understanding the compliance reason for the distinction shows the real enterprise maturity. What are the common wrong answers? Continuous integration is Jenkins, continuous delivery is Argo CD, continuous deployment is Kubernetes. Confusing tools with concepts. Naming tools as the answer to a concept question is immediate indicator of shallow understanding. What can be the follow-up questions that I would ask? What is the quality gate and where does it live in the CI/CD pipeline? How do you handle database migrations in CI/CD pipeline? What is deployment strategy like blue, green, canary, rolling? When do you use each? How do you implement rollback in automated deployment pipelines? I would give you the real production example. A SaaS platform I architected had four pipeline stages: build, where we used to build the Docker images, automate the unit testing, and the dynamic security scan, static code analysis. Staging deploy, so where integration test, smoke test, or the load test used to happen. Performance test, that's a K6 load test must meet the SLO thresholds. This is the actually capacity planning stage that we can uh, make our infrastructure ready with the actual load. And last one is the production deploy. Requires manual approval from release manager for compliances. This is the continuous release, not the deployment, because SOC 2 audit requirement that mandate a human release date. Pro tip: mention compliance constraints proactively in regulated industry, banking, healthcare, government. Full continuous deployment is often contractually or legally impossible. Knowing this distinction signals a real enterprise experience versus purely startup world thinking. The third question would be, what is infrastructure as code and why it is important? Infrastructure as a code is the practice of managing and provisioning computing infrastructure through machine readable configuration files rather than through manual process or interactive configuration tools. Instead of clicking through a cloud console to create VPC, subnet, EC2 instance, and security groups, you will write a Terraform or cloud formation file that describes the desired state of that infrastructure. That file lives in version control, is peered, reviewed, tested, and applied through a pipeline. ISC is important because it eliminates configuration depth, it eliminates reproducibility, allows infrastructure to be treated with the same engineering rigor as application code, and makes disaster recovery reliable and fast. What I'm for looking for understanding of mutable versus immutable infrastructure, declarative versus imperative approaches, and the concept of IC. Bonus is state management challenges in Terraform. Common mistakes, common wrong answers are IACs when you write YAML file for Kubernetes, Kubernetes manifest are workload configuration, not infrastructure provisioning. Confusing. Workload config with infrastructure provisioning is fundamental gap. What follow-up questions I would ask? What is the difference between declarative and imperative IAC? How do you manage Terraform state in a team environment? What is the configuration drift and how do you prevent it? How do you test infrastructure as a code before applying? For example, after a regional outage at telecom client, we needed to recreate an entire AWS environment. 3 VPCs, 12 subnets, RDS cluster, EKS clusters, IAM roles, security groups, WAF rules from the scratch. Because everything was in Terraform with a remote state in S3. We reprovisioned the complete environment in barely 47 minutes. Without IAC, the same rebuild would have taken days and would have introduced undocumented configuration differences. What's a pro tip? Always mention idempotency, the property that running the same IAC code multiple times produces the same result. The single word used correctly signals the deep understanding of why IAC works and why what it does. Now the fourth question I can ask, explain Kubernetes architecture and how you would design a production grade cluster. What I expect from candidate. Kubernetes has control plane and data plane. The control plane components are kube API server, the front door, all communication goes through it. HCD, distributed key value store, source of truth for cluster state. Kube scheduler, assign pods to nodes based on resource requirements and constraints. Kube controller manager, runs controller, deployment, replica sets, node namespaces, and optionally cloud controller manager for cloud provider integration. The data plane consists of worker nodes running kubelet, talks to API server, manages pod lifecycle on that node. The kube proxy manages network rules for service load balancing and the container runtime, container D or CRIO. For production grade cluster, multi-AZ control plane, worker node groups with auto scaling, separate node pools for separate different workload types, RBAC enforced, network policies applied, port security standards configured, resource quotas and limit ranges set, monitoring with Prometheus, Grafana, and GitOps with Argo CD for declarative management. As a hiring manager, what I would expect at senior level, I expect control plane versus data plane distinction without prompting. I expect awareness of HCD criticality. If HCD is down, the cluster is blind. And I expect production concerns, HA, RBAC, resource limit, observability, not just its schedule spot. Where most of the candidate fails. Kubernetes has master node and worker nodes, master controls everything, and worker runs the pod. So this is the textbook knowledge, not mentioning the core component of Kubernetes are like HCD API server, kubelet, individually or any production concerns. That signals the candidate has theoretical knowledge but has never run Kubernetes in production at scale. What would be the follow-up questions from me? What happens if HCD loses quorum? How do you recover? Walk me through a horizontal pod autoscaler. What metrics does it uses and what are its limitations? How do you implement zero downtime deployments in Kubernetes? What is the pod disruption budget and when would you use it? How do you secure pod to pod communication in multi-tenant cluster? Pro tip, mention HCD backup strategy unprompted. Say in production, I schedule HCD snapshot every 30 minutes to S3 and I test restore quarterly. Almost no candidate does this. It signals you have been in an incident where HCD data was at risk, which is real production experience. The fifth question, what I would ask, what is the difference between SRE and DevOps and how do they work together? As a hiring manager, what I expect from candidate, the answer is DevOps is a philosophy, set of cultural practices and principles for collaboration between development and operations. SRE or site reliability engineering is Google's implementation of DevOps principles using software engineering practices applied to operations. Ben Trenor-Sloss, who created SRE at Google, described it as what happens when you ask a software engineer to design an operation functions. The key SRE concepts are SLIs, service level indicators, actual measurements like latency, error rate, etc. SLOs, service level objectives, the target for those measurements, and SLAs, service level agreements, contractual commitments to customers. Error budgets, the acceptable amount of unreliability that can be burned before development must pause. And toil, repetitive manual work that should be automated. SRE cap toil at 50% of their time. 50% of time SREs are invested in automation. DevOps and SRE are complementary. DevOps provides the cultural foundation and delivery practices. SRE applies engineering rigor to operating system reliably at scale. What are the expectations from the candidate as a hiring manager? Looking for clear differentiation without positioning them as competing. The error budget concept, if the candidate can define and use it in context, it is the separator between someone who has read about SRE and someone who has practiced it. Common wrong answers is SRE is more focused on the reliability and DevOps is more focused on speed. They are basically the same thing. The answer is non-answer. It neither defines the SRE's specific practices nor shows any understanding of error budget, toil, or organizational structure difference. What are the follow-up questions that I would ask? How do you calculate an error budget? Give me the example with 99.9% SLO. What is your process for blameless post-mortem? How do you decide when to halt feature development to address the reliability depth? What is the difference between availability and reliability? Pro tip quote Ben Trenner's loss SRE is what happens when you ask a software engineer to design an operation functions. Using this quote correctly shows you have actually read the Google SRE book, not just the blog post about it or any other YouTube videos. Question number 6. How do you implement DevSecOps in a CI/CD pipeline? What I would expect as answer. DevSecOps integrates security throughout the software delivery lifecycle rather than as a gate at the end. In CI/CD pipeline, security is implemented in layers. In the commit build stage, pre-commit hooks with secret scanning like Git secrets, Git leaks, static application security testing or SaaS using the Sonar Cube, SemGraph, or check marks to detect vulnerabilities in source code and software composition analysis or SCA. To identify vulnerable third-party libraries in the container build stage, container image scanning using the Trivi Aqua container image scanning to detect OS and package vulnerabilities in Docker images before they are pushed to registry. In the test stage, dynamic application security testing or DAST. Running against a deployed instance in the deployment stage. Policy as code using Open Policy Agent or Kubernetes enforce the security. Security policies on Kubernetes workloads. Prevent privileged containers, enforce image signatures, require resource limits. In the runtime stage, runtime application cell protection or RASP, Falco for runtime threat detection. Network policies to restrict pod to pod traffic, generating SBOM, software bill of material for supply chain visibility is increasingly compliance requirement. What is expectation as hiring manager? I expect the candidate to understand the shift left concept and able to name at least 3 tool categories with specific tools in each area. Knowing software bill of material and supply chain security signal awareness of current enterprise requirements. What are the common answers, common wrong answers? We add security scanning at the end of the pipeline before going to production. This is exact opposite of DevSecOps. Moving security to the end defeats the entire purpose of shift left. This answer shows the candidate has not internalized the philosophy, they have just added security tool without understanding the reasoning. What are the follow-up questions that I would ask? How do you handle a critical CVE discovered in a base image used by 50 microservices? What is an SBOM, software bill of material, and when would a regulator ask you to produce one? How do you manage secrets in Kubernetes environment? What is difference between SAST and DAST? Pro tip: mention supply chain security. SBOM says we generated an SBOM, software bill of material, using SIF on every build and store it with the artifact. This lets us quickly identify which services are affected when new CVE is disclosed. Instead of graping through dozens of Docker file at 2 a.m. during incident, this level of operational maturity immediately signals senior plus experience. Question number 7 that I would suggest: design a multi-region, highly available deployment architecture for a mission critical microservice application with zero downtime requirements. What are the expected answers as DevOps engineer? Multi-region HA design starts with a clear definition of the availability target. For zero downtime requirements, we target 99.99% availability, approximate 52 minutes downtime per year. Architecture: two active regions, active active, with a primary and secondary that can both serve traffic simultaneously. Global load balancing via AWS Route 53 or Azure Traffic Manager with latency based routing and health check failures. Each region runs on EKS AKS cluster with multi-EZ worker node groups spanning at least 3 availability zones. Application tier: stateless microservices deployed with at least 2 replicas per asset. PDB, pod disruption budget, set to prevent more 30% pod eviction simultaneously. HPA based on CPU and custom metrics. Data tier: multi-region RDS with automatic failure, read replicas in each region, global tables for DynamoDB where applicable. Cache layer: elastic cache Redis with cross-region replication, deployment strategy, progressive delivery using Argo CD rollouts. Canary deployments with automated analysis using Prometheus metrics, automated rollbacks if error rate exceeds SLO threshold. Observability: single pane of glass monitoring across regions in Datadog or Grafana with cross-region alerting. Chaos engineering: quarterly to validate failure actually works, runbook tested, not just written. What are my expectations as hiring manager? This is the principal or director level question. I am evaluating structured thinking, trade-offs awareness, active, passive, cost implications, data consistency challenges across regions, and whether the candidate mentioned testing the architecture, not just designing it. Anyone can draw a diagram. Can they validate it works? What are the common wrong answers? We deploy 2 regions and use load balancer in front. This is architecture by keywords, not by design. No mention of data replication strategy, no failure mechanism, no deployment strategy, no testing. At senior level, this answer suggests the candidate can talk about concepts but not design and operated system at the scale. How then? What are the follow-up questions that I would ask? How do you handle database write conflicts in an active multi-region setups? What is the cost implications of active versus active passive, and how do you justify it? How do you test regional failures without impacting the production? Walk me through what happens at minute zero of complete regional failures. Pro tip: always close architecture answer by saying you would validate it with chaos engineering or game day exercise. Any senior engineer can draw an architecture that the one who tests it under production conditions, that is the person directors want to hire. Chaos engineering is the mark of mature engineering culture. Question number 8. This is very advanced question. How do you build and operate a platform engineering function at scale? What is an internal developer platform? What I would expect as engineering hiring manager, platform engineering is the discipline of designing and building tool chains and workflows that enables software engineering organizations to deliver and operate software efficiently at scale. The core product is an internal development developer platform or IDP, a self-service layer that abstracts away infrastructure complexity and provides golden paths for developers. A mature IDP provides self-service environment provisioning, developers spin-off staging environment without waiting for ops, standardized CI/CD pipeline templates, service catalogs like Backstage or Port, showing all services, their ownership, SLOs, and documentation. Golden Path templates for new services that embed security, observability, and compliance from day one. Secret management, self service, cost visibility per service and team, and compliance automation that runs without developer involvement. The platform team treats developers as their customer. They run quarterly developer experience surveys. They measure success by developer productivity metrics, DORA metrics, time to onboard a new service, time to provision an environment. Platform engineering is not about owning all infrastructure. It is about reducing cognitive load on product engineers so that they can focus on delivering business values. In this, as hiring manager, what would be my expectations, especially looking for understanding of platform as a product, internal customer product mindsets, developers, NPS, golden paths concept, not golden cages, and DORA metrics as a success measure. Backstage or port knowledge is plus but not mandatory. The philosophy matters more than the tool. What are the common wrong answers? Platform engineering is when one team manages all infrastructure so developers do not have to worry about it. This is the old ops gatekeeping model rebranded. A true platform engineering team empowers developers with self service. It does not create new bottleneck. This answer shows the candidate has heard the term but does not understand the paradigm shift. What can be the follow up questions? How do you measure the success of platform engineering team? What is the difference between golden path and golden cage? How do you handle the tension between standardized and developer autonomy? How do you build a platform team from scratch? Hiring profiles, first 90 days priorities. Pro tip: use phrase platform as a product. Say we treat our platform like a product, our developers like customers, and we run quarterly NPS surveys to measure their satisfaction. This single framing immediately signals you understanding the modern platform engineering philosophy, not the old ops team with the new name. Question number 9, I would prefer the scenario based question. Your production Kubernetes cluster is just started evicting pods at 3 a.m. You're on call, SRE wakes you up. Walk me through your incident response step by step. What I would expect, like step 1, acknowledge and communicate. Immediately post in the incident Slack channel, declare incident severity, open a war room, assign incident commander, and communicate lead roles. Step 2, triage. Check kubectl describe nodes. What is the eviction message? It is memory pressure, disk pressure, or PID pressure. Check cluster level events, Kubernetes get events, sort by that metadata, creation timestamp, etc. Step 3, identify root cause. Is it specific node, specific namespace, or cluster wide? Check node metrics in Grafana, memory utilization, disk utilization. If memory pressure, which pod are consuming memory beyond their limits? kubectl top pods command hyphen all namespaces. Check if the deployment changed the resource request or the limits. Step 4, containment. If one node is failing, coordinate to prevent new scheduling. kubectl coordinate node. If a specific workload is out of memory killing, temporarily scale down or apply a resource limit patch. Step 5, recovery. If node is irrecoverable, drain and terminate it. Then replace via auto scaling group. Verify pods, rescheduling on healthy nodes. Step 6, communication. Update stakeholders every 15 minutes during the active incident. And the last step, step 7, postmortem. Blameless within 48 hours with timeline, root cause, impact, and concrete action items with owners and due dates. As a hiring manager, what I would expect? I am testing incident response maturity. The technical commands are secondary. What I really watch for, does the candidate immediately communicates? Do they assign an IC? Do they think about the containment before resolution? Do they mention postmortems if a candidate only talks about kubectl commands without mentioning communication or blameless culture? They are technician, not engineering leaders. Where most of the candidate fields, I would SSH into the node and check what is happening. The restart pods on the node, no communication, no incident structure, no root cause analysis, no postmortem. Restarting nodes without understanding why is the fastest way to run P1, P2, no postmortem. Restarting nodes without understanding why is the fastest turn a P2 into P1. This answer reveals a candidate who has only worked on small teams without incident management process. What can be the follow-up questions? How do you prevent this from happening again? What changes to your resource management would you make? How do you run a blameless postmortem with a team that has blame culture? What monitoring alerts should have fired before pod started being evicted? How do you communicate a P1 incident to executive stakeholders who do not understand Kubernetes? Pro tip, use the phrase incident commander IC and blameless postmortems. Within your first two sentences, these two terms signal that you operate with engineering maturity, structured incident response, not heroic firefighting. Hiring managers at director level are specifically looking for candidates who can build incident culture, not just survive incidents. Question number 10, scenario based question again. Your CTO asks you to reduce cloud cost by 40% without impacting the reliability or team velocity. You have 90 days mandate. What is your plan? Expected answer would be day 1 to 15. Visibility and baseline. Enable cloud cost management tooling like AWS cost explorer management or third party like Aptio cloudability. Tag every resource, team environment, service, cost centers, generate cost breakdowns by service and identify top 20 cost drivers. Day 16 to 30 quick wins. Identify idle or orphaned resources, unattached EBS volumes, unused elastic IPs, stopped EC2 instances, unused load balancers or old snapshots, right size EC2 and RDS instances using AWS Compute Optimizer recommendations, typically 20 to 30% savings with minimal risk. Convert on demand instances for predictable workloads to reserve instances or saving plans. This saves 30 to 60% discount. Day 30 to 60 architectural changes. Implement autoscaling on all stateless workloads, EKS node groups via Carpenter, Lambda for event-driven workloads. Convert batch and non-time sensitive workloads to spot instances with fallback strategy. Identify over-provisioned RDS instances and right size with multi-AZ only where actually needed. Implement S3 intelligent tiering and lifecycle policies for object storage. Day 61 to 90. Culture and governance. Implement per team cost dashboard. Establish monthly FinOps reviews with engineering leads. Set up budget alerts and anomaly detection. Create engineering incentives for cost efficiency, present result, and sustainability plan to CTO. 40% reduction is aggressive but achievable if the baseline has significant orphaned resources and over provisioning, common in fast growing organizations. This is director level question. I want to see structured 90 days plan, not random cost cutting, FinOps discipline, quick wins versus architectural changes, distinctions, and criticality. Cost culture, not just a cost tool. The candidate who only talks about the reserve instance without mentioning visibility, tagging, and governance is thinking tactically. The one who talks about FinOps culture is thinking strategically. The common wrong answers are I would buy reserve instance and use spot instances instead of on demand. This is one tactic, not a plan. No mention of visibility. You cannot optimize what you cannot see, right? No mention of governance, no mention, no structured approach, no consideration of reliability trade-offs of spot instances for critical workload. This answer shows someone who has read one article about the cost optimizations. What can be the follow-up questions? How do you convince engineering teams to care about cloud cost when they are measured on feature delivery? What is FinOps and how do you implement it organizationally? How do you balance cost reduction with reliability SLOs? What is the risk of spot instances for payment processing service and how do you mitigate it? Pro tip, say the word FinOps and define it. FinOps is a practice of bringing financial accountability to cloud spending through cross functional collaboration between engineering, finance, and business. Then say the technology is easy part. The hard part is changing engineering culture so teams care about cost without compromising velocity. This answer structure works for director level interviews at any organization. I will create a separate video on real world production scenarios so where we can discuss about the different domains like banking, SaaS, healthcare, telecom, and other domains. So now I would like to mention that what interviewer actually looks for. Let me tell you what I'm actually evaluating when I interview a DevOps candidate. It's not whether you can recite Kubernetes components. I can find that in documentation. Here is what I genuinely look for: structured thinking under pressure, trade off awareness, production war stories, communication without jargons. What makes candidates stands out mostly like the if you have the great understanding of the DORA metrics, SLAs, SLIs, SLOs, referencing platform engineering, etc. What gets the candidate rejected? I have declined more offers than I care to count. Here are 12 patterns I see again and again that end interviews before they should end. First, answering What is DevOps with tool list? Confusing continuous delivery with the continuous deployment, claiming expertise in tools you have never operated in production, saying I would Google it for foundational Linux or networking questions, never having conducted or participated in the postmortems, inability to estimate capacity, cost, time, no understanding of cost implications, cannot explain their own resume, blaming previous teams or managers, treating security as an afterthought, no curiosity about the role or company, and overconfidence without depth. So, the last director's advice, the principles that actually shapes careers. I have spent 18 years in this field. I want to give you the advice that I wish someone had given me when I was preparing for my first senior role. These are not interview tips, these are the career principles. Own the problem, not just the task. Learn the business you're serving. Build in public. Specialize and be able to generalize. Invest in soft skill as seriously as technical skills. Do not chase titles, chase problems. And finally, the most important advice I can give, be honest in interviews. The hiring manager across from you has been in your seat. They know what the real production experience looks like, they know what imposter syndrome sounds like. They are not trying to trick you, they are trying to find out if you are kind of engineer they want to work with every day. So that honesty combined with demonstrated competence is the most powerful combination in any interview room. The summary, everything that you need to remember, what you have learned, how to answer these questions, and how to present yourself, how to tell about what is DevOps. DevOps is a cultural movement, not the tool, not the platform. What to do next? Before you close this video, I need you to do one thing, not subscribe, though I appreciate it if you subscribe, not like, though it helps the algorithm. One thing that will actually change your career. Practice one of these 10 questions out loud right now before you do anything. Do not read answers. Put down the phones or close the laptop for 60 seconds and answer the question from memory. Record yourself on your phone, play it back. You will hear gaps you did not know you had. Fill those gaps. That's how you prepare for interviews, not by consuming content, but producing answers. Episode 2 is already in production. We are going to deep on CI/CD, how to design a pipeline from scratch, the most common pipeline failures in production, and the exact question I ask about Jenkins, GitHub Actions, and Argo CD at every seniority level. If this episode gave you one insight you did not have before, subscribe and share it with one engineer you know who is preparing for an interview. This is the best thing you can do for this channel and for community. I will see you in the next episode inside the interview room.